Welcome back. Geometry folder number 2, vertical and adjacent angles. Your objective for this video: you should be able to correctly identify vertical and adjacent angles and their measurements. You will need graphic organizer number 6, side number 2. This is not side number 2. You will need the back side to this piece of paper, and we will be working at the top and the challenge problem at the bottom. On your graphic organizer, you will see this challenge problem. Our goal is for us to be able to solve this problem today without any issues. It says, if the measure of angle 2 is 50 degrees, can you find out the measure of the rest of the angles? That is what we will be doing today. Okay? We're going to start with a little introduction. This is a video. I repeat, this is a video. It is not me. Enjoy. Good luck.
In this video, we are going to be talking about two different types of angles. The first are vertical or opposite angles. You can call them either. You could call them vertical angles, or you could call them opposite angles. And then also we'll be learning about adjacent angles. The first type of angles are vertical or opposite angles. Vertical or opposite angles are angles that are opposite each other. Very easy to remember because you can think about opposite means across from. So here we've highlighted two opposite or vertical angles. So angle ABE is opposite angle CBD. There's another set of vertical or opposite angles in this picture, highlighting in green. Again, they are across from each other or opposite each other. So angle ABC is opposite angle EBD.
Adjacent angles are right next to each other. Now, they're two separate angles, but they are right next to each other. They're like neighbors. So if we take a look here, angle LNM is adjacent or next to angle ONM. So again, these angles are two separate angles, as you can tell. It looks like angle LNM is an acute angle, while angle ONM is an obtuse angle. And again, they are right next to each other, and they share one of their
rays. So it's almost like thinking about neighbors sharing a fence that's between the 2 yards. So there's two different angles sharing that fence or that ray.
Okay, I'm going to be honest. I like that analogy. It's a fence. So if you look right there, and we'll see this guy right there, that line, that's a fence. It's separating the neighbor's yard. Okay? Adjacent angles have that fence. They're right next to each other. They share that same fence. That's all we need to know. All right? We're going to continue. Let them keep playing.
Again, let's look at some adjacent angles here. So we want to look at angles that share the same fence or the same ray. So let's look at angle EBA and then angle DBC. Now notice how these angles don't share a whole fence. They've only got a corner here. So these would be opposite angles. Now let's look for an angle that would be adjacent to angle EBA. We can look here, and I'm noticing that angle CBA shares a whole side here, a whole ray with angle EBA. So we can say that angle EBA is adjacent to angle CBA. Now, what angle do you think would be adjacent to angle CBD?
All right. So we're going to go ahead and keep moving on. We're not going to listen to the math aids. Here we go. So what are adjacent angles? Quite simply, adjacent angles are side by side, and they share a common ray. Hint, graphic organizer. They are side by side and share a common ray. If you look at this purple line, that is the common fence or the common ray. Both angles share that fence, so they are side by side. That makes them adjacent angles. All right. Here are some more examples of adjacent angles. Notice in each one of them, they share a common ray. The only one that is off, and I'm not sure why, is this one at the top right, when it should have something like this. Don't worry about that green line if you see it. Okay, all of these share a common ray. Common ray I will highlight in pink on all of them, all right, which would be here, here, and here. Moving on. Okay? These angles are not adjacent. Why are they not adjacent? Well, these ones are not adjacent because they do not share a common fence line or a common ray. If you see here, there's a gap. Okay, through that gap, well, guess what? The dog's going to run through that. That is not a common fence. Okay, you see down here in the bottom, there is another angle over here. This angle right here, it separates those, so they don't share a common ray. And these two, those aren't going to work either. Those are actually opposite angles, which we call vertical angles, which is right now. So let's move on. Vertical angles, what are they? Well, vertical angles are when two lines intersect. They make vertical angles. So when two lines intersect, they meet at a cross, and they're at the same angle. They're not squiggly lines, they're straight. So what happens is we get what we call vertical angles. And vertical angles are really cool because they're opposite one another. But not only are they opposite one another, they're also congruent. So what you need to write for your definition and for your graphic organizer is vertical angles are opposite one another and congruent, which you will see in this next video. The 75 degrees and the 75 degrees are vertical angles. They are opposite each other. One's at the top, one's at the bottom, but they are met together with the same exact two lines. So if you see this line and this line meet together, they form two angles, this one and this one. Okay, those two are opposite from each other. You also have these two on this side. Those are also vertical angles because they're opposite as well. Okay, so 105 degrees and 105 degrees are also vertical angles. Now, I told you to make sure that you wrote in your graphic organizer that vertical angles are congruent. What does congruent mean? Well, congruent means equal. So, they are equal. That means same size, same shape. Right? So, we have two sets of vertical angles in this particular place. Now, I'll let you listen to this guy. Okay, and we're going to go ahead and get started now.
We speak student.
Vertical angle theorem. Allah shmup. Mr. and Mrs. Thimbleton have just celebrated their 63rd wedding anniversary. They're in the prime of their lives and just as in love as they were all those years ago. They're also just as thrill-seeking as they were back then, too, but without the parole violations. So to celebrate, these 82-year-old daredevils decided to go bungee jumping together. Let's just hope they don't lose their dentures. If they both jump in opposite directions and don't hit each other, they'll make vertical angles. If the angle the bungee cords make at the very top is 52 degrees, what angle will they make at the bottom? Okay, to start, let's look at Mr. Thimbleton's bungee cord. Since it's a straight line, we know it makes a 180-degree angle. That means our top angle plus this angle on the side make a linear pair. Two angles that are supplementary.
I love vitamins.
And adjacent.
Adjacent who?
Since they're supplementary, we know they add up to 180 degrees. And because we know the top angle is 52 degrees, we can find the side angle by subtracting. That's 180 minus 52. And the angle on the side is 128 degrees. We're looking for the measure of the very bottom angle. Let's consider Mrs. Thimbleton's bungee cord. It also makes a 180-degree angle, which means the side angle we just found and the bottom angle also add up to 180 degrees. If we take 180 minus 128, we end up with 52 degrees as the measure of the bottom angle. Let's find the measure of the last angle. If we go through the same process and pick out a supplementary linear pair, we'll calculate 180 degrees minus 52 degrees equals 128 degrees. So really, vertical angles are any two opposite angles formed by intersecting lines. And the vertical angle theorem says that vertical angles are congruent. In other words, their angles are equal. Is this true? Here we have two pairs of vertical angles, the top and bottom each measuring 52 degrees, and on the right and left each measuring 128 degrees. So yes, vertical angles, even if they're horizontal, are congruent. Now you can be as secure with your knowledge of vertical angles as the Thimbletons are to their huge bungee cord. And to their dentures, too, we hope.
Okay, guys, we're going to go ahead and move on. So, this problem. If I told you guys that angle 2 was 40 degrees, you should be able to figure out 1, 3, and 4. Basically, you can figure out 4 very easily, because 4 and 2 create opposite or vertical angles. So 4 is 40 degrees. Remember, vertical angles are congruent. So how do I find number 1 and 3? Well, if we remember correctly, adjacent angles. Those are adjacent. Number 2 and 3 are adjacent, but they also create a straight line. And when we create a straight line, that means not only are they adjacent, but they're also supplementary, because supplementary angles add up to 180 degrees. So how do we find number 3? Well, you simply take 180 and you subtract the 40 that you already have, which would give you 140 degrees. Now that we know that one, we also know number 1, because number 1 is a vertical angle to number 3, which means it is opposite and congruent. So here's our challenge problem. I want you to try this one on your own. I will give you a little hint. Okay? It says measure of angle 2 is 50 degrees. So this is, 52 degrees. That's 52. I am going to tell you that this right here is definitely a right angle, and this one is also a right angle. So knowing that you have those two right angles, you should be able to figure out everything else in this problem. When you're done, show it to me. Mr. William really wants to check this. This is super important stuff, and it's very vocabulary laden. So good luck, and we'll see you tomorrow.